This is a video on sound waves conducting through the ear. So basically what happens is the pinna acts as a funnel for sound waves so that we can concentrate the waves to enter the external auditory meatus and move through the canal. So as the sound wave moves through the canal, it eventually hits the tympanic membrane. When you hit the tympanic membrane vibrates. Okay? So vibrations of the tympanic membrane occur because sound waves are bumping into it. As the tympanic membrane vibrates, it's then going to vibrate the first bony ossicle that's attached to the tympanic membrane, which is the malleus. So vibrations of the eardrum cause vibrations of the malleus. Vibrations of the malleus cause vibrations of the incus, okay, which is the second ear bone. And then vibrations of the incus are transmitted to vibrations of the stapes. So it goes tympanic membrane, malleus, incus, and stapes, sound wave turned into a bony vibration. Once you have the stapes moving, okay, so the stapes is now vibrating, and it vibrates through that opening called the oval window. Okay? So vibrations of the stapes through the oval window is what actually creates waves of the fluid that exists inside the cochlea and inside the semicircular canals. Okay? And the fluid inside the cochlea is known as perilymph and endolymph. It would be similar to dropping a rock in a pond. So if you drop a rock in a pond, it creates ripples in the water, and that's essentially what the stapes is doing. It's creating ripples inside the cochlea. And so as those waves move through the cochlea, depending upon what kind of wave it is, okay, which was based off of the frequency of sound that caused the vibrations, it's going to activate a certain part of the cochlea, specific hair cells. So inside the cochlea, there would be specific hair cells that get activated in the organ of Corti, and those hair cells, once they become active, will send information along the cochlear branch of the vestibulocochlear nerve, and then that eventually travels to the thalamus, and then eventually out to the auditory cortex of the brain.